Hello friends, today I'm going to talk about Leetcode 14.16 restore the array. The problem is that you are given a program that is broken that doesn't print the white spaces in an array. You are trying to find out how many possible ways that they can be constructed for the possible array with a given string. And also you have the limitation that the value in each possible array formed is between the range 1 to k. And here is the example. Here we have s equal to 1. This string has 1000 and the range is 1 to 10,000, and there's only one way that could be the possible array, that is 1000. You cannot find any other way that is valid because there's no leading zeros that is valid. And here's another example here, and for this example we have 1317. The value is less than 2000, and we have this 8 possible this possible arrays that each element in the array that has the value less than 2000. And let's look at more example to explain this. For this problem, for example, we have the 1317 and 2000, and we have all this possible result, right? So it seems that we could split the data from 1 or 13 or 117 or 117. So it has sub problem was inserted, and also recursive is involved. So it is actually we can use a backtracking technique that travels this array and find out all the possible sub array that has value that is smaller than k. It's like this. We start from the root, and here is 1 here. Like maybe if we don't consider this red 9, and when we consider this black 9, this 117, and when we travels back, it will have 117 as an element, and when we travels back, the was 317, and also 317, and also 13 and 17 or 17, and etc. So each element here, this 1317 is a possible array, and this is 117 is another possible array. So we have total have this 8 arrays. This can be used recursive way to backtrack this, because if we don't use memorization, it will be exponential time complexity. So we can use memorization here. And this is actually called top-down dynamic programming. The basic call function is defined over here. The have function with sk, and the current index is when it's traversing, and also the memorization and array or hash map. So we can first we consider base case. Base case is that if the index is currently equal to the length of the string, that is mean we have traversed all the element in the string, so we put the possible result. If the result current result so far is smaller than the k, we will put in this answer, and then we check whether its index is so far is visited or not. If it's already visited, we just retrieve the answers from the memory, and then we traverse from index to the next and get the current index. If current number is valid, that is smaller than k, then we will recursively call this function again with the index 1 here, and this is plus 1 result, because we are going to return the number of arrays, so it's plus 0 here. So basically this is the recursive way. Here I'm going to talk about the bottom up. That is another way to solve this dynamic programming. We define the DPI as the number of possible arrays that is valid from index I to the last index, that is to the end of this array n-1, and we will find out the DPI equal to DPI plus DPJ. For j should be this one here. J should be between I to the m should be, and this y it is. So let's consider for example, we have already known the DPJ, where the DPJ is already known, and we need to find out the DPI over here. So we need to find out whether the numbers formed between the I and j is valid, and if it is valid, it means that there's a possible subarray formed between I to the n, and because we already know that DPJ is valid, and DPJ is the number of possible arrays. DPJ is this from j to n is already, we know how many numbers, and then we just plus the DPJ. So we have to figure out when j is over here, and this DPRJ whether it's valid. If it's valid, we will plus the DPJ again. When DPJ is over here, so we have to find out how many D and J exist between I and N, and we also to make sure the substring between I and J is valid. So basically this is the recursive function here, and for j between I plus 1 that's n minus 1, and the final output should be dp0, because from 0, because it is defined from 0 to n, the number of possible arrays. So let's write code now. So first we define the n is number of this is the size of the string, and define the dp array to the number of the array formed from index I to the to the m. DPI is the number of indexes from I to the n. And then we consider the modulo because the return value could be huge. And then we iterate from m-1 to the 0 backward traversing because we define in this way. Actually, we can define from 0 to the index from 0 to the index I. Then in that way we will return the dpn -1 dpn as the final answer, and we will traverse forward. So that method is similar as this method. That is just the way. One is forward traversing, the other is backward traversing. So we get the current numbers and j equal to from the I+1 to m, and also if we check the num whether it is valid, and if it's valid, then we plus dpj. And if it's not number, we will get the integer formed between that index I and the index j. So we will times 10. If it's other, we will do times 10, and also plus the characters values, integer values, then j+1. So we return this as the final answer. So this is basically the code. Oh, something is wrong here. Num should be bigger than 0. Oh, we didn't initialize for the first. If it's empty, this is something like empty. If it's empty, we should initialize the number of the n equal to dpn equal to 1 here. Yes, okay. Yeah, we made it.